Okay, so let's talk about one more disorder. I'll do one more practice problem for you for Hardy-Weinberg equilibrium. This time we'll talk about albinism. You guys have probably heard about this before. Albinism. This is a recessive disorder. Recessive disorder leads to an inability to produce melanin, which leads to that very white skin. It has a frequency of about 1 in 17,000 people actually has this disorder. 1 in 17,000 have albinism among humans, among human populations. Have albinism. Okay, so if I asked you the question, how many humans are carriers for albinism in the world? I'll put worldwide here. Worldwide. Could you answer that question based on this information, assuming that this population again is non-evolving or is in Hardy-Weinberg equilibrium? Well, as you guys have probably seen me do before, I'm going to draw a line down the middle, right? On the left side, I'm going to put alleles. These are my alleles. On the right side, I'm going to put genotypes. Genotypes. Okay, alleles. I'm going to use the alleles A, big A, and little a. Okay, of course, the Hardy-Weinberg variable representing these is P and Q. Okay, this is a recessive trait, recessive disorder, meaning that the allele that is going to give rise to this is the lowercase letter, right? So that is going to be this one right here, right? Genotypes. Well, we got big A, represented by our Hardy-Weinberg variable, P squared. We've got big A, little a, right? This is 2PQ. I'm going to draw my dotted line again here. This is just how I think it might make it easier for you. Way down here we have little a, right? This is Q squared. Equals. So I want you to pause the video. First thing I want you to do is I want you to write the fraction 1 over 17,000, because this is our frequency, that have albinism. Write that wherever it belongs on this on your page right now, if you followed along and you've written all this down. Go ahead and pause it, and we'll come back and we'll see if you were right. Okay, you should have written 1 over 17,000 right over here. Now, of course, I prefer working with decimals, as opposed to this in general, because it's going to get really messy anyways once we start square rooting stuff. But if you want, you can leave this as a fraction and just square root it. But I'm going to go ahead and put this in the calculator, so especially because I want you guys to see how to deal with one of these weird problems that some people have not been able to deal with. Okay, pull my calculator over here. All right, so 1 divided by 17,000. It's going to give me, and you're going to get something like this, 5.88 e negative 5. That e negative 5 trips a lot of people up. It's really not too bad once you understand it. What this means is, and let me erase this. Let me get my calculator back. One moment. Okay, so what this means right here is 5.88 times 10 to the negative 5, right? So I can write this as, and this is called scientific notation, 5.88 times 10 to the negative 5. Or, I'll put this out to the side so you guys can actually see it written out, 0.0000588. You simply move the decimal place over this many times, 5 times in this case. So if the decimal started here, you go 1, 2, 1, 2, okay. 1, 2, 3, 4, 5. I'm sorry, this computer is being ridiculous right now, but you get the drift. You move the decimal over that many times. Okay. So, you have Q squared. Can you solve this? The answer is yes. All you do is, and I'll write it down here, Q squared is equal to 5.88 times 10 to the negative 5. Or if you want to input it in your calculator this way, that might be a little bit easier for you. Square root both sides. Okay, I'm going to bring my calculator over here, and we'll get that done. Okay, so 0.000058. Let's square root that. Okay, and we get 0.0076, or 0077 rather, for Q, right? So Q is equal to 0.0077. So Q is equal to 0.0077, right? So I'm going to write that over here, 0.0077. Okay, now as you know, and when we're dealing with stuff like this, P plus Q equals 1. If we want to solve for P, we simply subtract Q from both sides, right? And we're left with P is equal to 1 minus Q. Okay, so could you input this in your calculator? 1 minus 0.0077. That will give you P. So go ahead and do that. Pause. Okay, so I'm going to pull out my calculator here. 1 minus 0.0077. All right, 0.9923 for P. So I can come over here and write 0.9923, right? That should all equal 1. You can put it in your calculator and check it if you want. Make sure they still equal 1. But we also know, of course, over here, P squared plus 2PQ plus Q squared is also equal to 1. Okay. So, P squared. First one, or actually, which one did I ask you for? Let's see. How many humans are carriers for albinism? So, first thing you have to ask yourself is, which one of these genotype represents a carrier for albinism? Well, we know that a carrier is somebody that carries that recessive allele, but does not show the trait. That would be your 2PQ population. So this one right here. So really, all we need to do is solve for 2PQ, multiply it into the worldwide population, and we'll know how many carriers we would expect. So, you're going to need your calculator again. Go ahead and solve 2PQ. Pause it and solve. Okay. I'm going to solve it here in this calculator. 2 times, and be very careful. Make sure you're looking at P and Q and not over here at P squared and Q squared. 2 times is a common mistake. 0.9923 times 0.0077 is going to give you 0.015281. We'll round this to 0.0153. There we go. 0.0153. 0.0153. Now we just need to multiply this times the world population. So let me go ahead and tell you how many approximate human population, Earth. Let's see. According to Wikipedia, we're about at 7.7 billion people approximately. All right, so we would have to multiply, where is it? Sorry about that. 7.7 billion people, which is, of course, billion, right? 7.7 billion people. I'll pull out my calculator and do that, and that will give us our correct answer. Okay, so 0.0153 times 7000000. That should be, yes, 7.7 billion. It's going to give me about 117 million, 117.8 million, right? So that's how many people you would expect to be a carrier in this population. Okay, I think that's it for this one. Let me write this answer down. 117. Oh, 000. This is how many you would expect to carry that recessive allele. Worldwide, 117,810,000. So if you got this, good job. Good job. Now, this again, keep in mind, just to backtrack a little bit, this is only for populations that are not evolving at a certain allele. So if you're not evolving at this specific locus on the gene, then this is what you would expect to get. Okay, I think that's it for Hardy-Weinberg practice. I hope that helped.